You know the story of Nicolaus Copernicus, right? This lone genius who, back in 1543, drops a book that just changes everything. One big idea. The Earth revolves around the sun. And boom, 1,400 years of astronomy get tossed out the window. It's a fantastic story. But what if it's not the whole story?
Right, let's get straight to it, because this is the question that really matters. When Copernicus's book actually came out, was his model any better? Was it more accurate than the old, Earth-centered one everyone was used to? Well, the answer is way more complicated and, honestly, a lot more fascinating than the simple legend you learned in school.
So the legend, the one we all know, goes something like this. You've got Copernicus, this brilliant astronomer who looks at the old Earth-centered system and thinks, wow, this is a total mess. So he comes up with this simple, beautiful model with the sun at the center, and bam, the world of science sees the light. It's clean, it's simple, it's a revolution overnight. Yeah, that whole story kind of hangs on this one idea, that his book was a total knockout punch, that its superiority was so obvious that it was immediately convincing. So we're going to put that whole story to the test by taking on 3 of the biggest myths surrounding it.
Okay, first up, was the whole idea of a sun-centered universe totally new? Did Copernicus just pull this out of thin air? Spoiler alert, not even close. Turns out he was standing on the shoulders of some very, very old giants.
What's so wild about this slide is just the sheer amount of time we're talking about. I mean, look at this. All the way back in the 3rd century BCE, a Greek astronomer, Aristarchus of Samos, actually proposed a sun-centered model. Copernicus even mentioned him in an early draft of his book. And then, centuries later, you have these incredible Islamic astronomers at a place called the Maragahey School who developed mathematical tools that were uncannily similar to what Copernicus would eventually use. So while Copernicus was the one to give the idea its first full mathematical workout, he was really just joining a conversation that had been going on for a very, very long time.
Okay, so the idea wasn't brand new. Fine, but surely his model was better, right? It had to be more accurate? Well, this is probably the biggest myth of them all. Let's actually see what astronomers back in the 16th century were working with.
Now, on the surface, the difference seems super simple. Ptolemy's system had a fixed Earth right in the middle. Copernicus put the sun near the middle, with the Earth and all the other planets orbiting it. And you know, this was a really elegant way to explain weird things like retrograde motion, that strange backward loop planets seem to do in the night sky. But here is the major twist. To make the math actually line up with what they saw in the sky, both systems were incredibly complicated. See, both Ptolemy and Copernicus were stuck on this old idea that orbits had to be perfect circles, which we now know they aren't. So to make it work, they both had to use these complex little gadgets called epicycles. Think of them as little circles riding on top of bigger circles. And here's the real kicker. Both systems needed over 30 of these things to function. So much for being simpler, right? So, the big question, which one was more accurate? Luckily for us, we have the notebooks of the legendary astronomer Tycho Brahe. He meticulously compared the predictions from both models to what he was actually seeing. And just look at this scorecard from one night in 1564. For Venus and Saturn, Ptolemy's old model was actually closer to the truth. But for Mars and Jupiter, Copernicus nailed it. So what does that mean? It was basically a tie. And this just perfectly captures the problem for any astronomer living in the 16th century. There was just no clear, data-driven reason to throw away 1,400 years of tradition for this new theory. When it came to just predicting where the planets would be, the Copernican model simply wasn't a slam dunk. All right, let's tackle our 3rd and final myth. If the model wasn't a clear winner, maybe Copernicus himself just willed it into existence? You know, was he this bold, fearless revolutionary fighting for his ideas against all odds? These are his own words, right from the preface of his book. Now, does that sound like a confident firebrand to you, or does it sound more like someone who is deeply worried about getting criticized? He's already calling out the babblers and fault-finders. He was bracing himself for the storm he knew was coming. In fact, the story of how this book even got published is just one of extreme caution. Copernicus worked out his theory decades before it ever saw print, only sharing a short little summary with a few friends. It actually took a young, energetic professor named Rethicus 2 full years just to convince the old man to finally publish his life's work. And even then, get this, a theologian added an anonymous preface without Copernicus's permission, basically saying, hey, don't worry, this is all just a math tool, it's not real, just to soften the blow. This was not a guy storming the castle. Okay, so if the idea wasn't really new, and the model wasn't clearly more accurate, and the man himself was super hesitant, then why on earth do we call it the Copernican Revolution? Why does it matter so much?
Because its true power, its real genius, wasn't it being perfect right out of the box. It was in the new framework it gave to everyone. It offered a coherent physical system. And it was this new way of thinking that completely unlocked the future. It was this system that allowed Johannes Kepler to finally realize that planets don't move in perfect circles. They move in ellipses. It's what gave meaning to Galileo's discoveries with his telescope, like when he saw the phases of Venus, which proved it had to be orbiting the sun. The book wasn't the finish line. It was the starting gun for all of modern astronomy.
So when you really think about it, the Copernican Revolution wasn't this sudden flash of perfect genius. It was the messy, slow, kind of hesitant beginning of a new idea. It was an imperfect first draft that took other giants, like Kepler and Galileo, to revise and eventually prove right. It kind of makes you wonder, doesn't it? What bit of settled science today is just waiting for its own Kepler to come along and find the one missing piece?